Here is everything for you to know about differentiation. Differentiation is the process of getting the derivative of a function. A function is a mapping that is one-to-one or many-to-one. The derivative is given by this formula. It can also be thought of the rate of change at that point, or the slope of tangent to a curve at the particular point. More of this later. But what is this symbol here? In simplest words, the limit of an expression is the value that the expression approaches when the variable is approaching a specific point. With this definition on hold, we can then start to derive some standard derivatives. For a polynomial, we see that it is just multiplying the power and then reduce the power by 1. Here are some more standard results, but it would require more advanced theories to prove it, so let's leave it for the next time. With the standard results on hold, we move on to the rules of differentiation. First, for the sum or difference of functions, the derivatives are the sums or differences respectively. For a composite function, we have the chain rule, which is basically differentiating the outer function and then multiplying by the derivative of the inner function. Now for a product of functions, we have the product rule, which looks like this. We differentiate one by one whilst keeping the other untouched, and then add the two together. Now for a quotient, it gets a little bit complicated at first glance, but it is actually a special case for the product rule. So now we know how to find derivatives, let's move on to the applications. We mentioned above that the derivative at a point can be thought of as the slope of the tangent at that specific point. A tangent to a point is a straight line that is parallel to the curve at that point. So the tangent of the point is given by this general formula. Since we know that the point is where the line and curve intersects, we can derive the formula of the tangent. The tangents also play an important role in determining the shapes of the curve. In particular, it can show the monotonicity of the function. If the gradient is non-negative for all values, then the curve is an increasing function and vice versa. On the other hand, if the curve is a mixed function, then there are some turning points, which is where the derivatives at those points are 0. If the curve changes from increasing to decreasing, the point is called local maxima, whereas if the curve changes from decreasing to increasing, the point is regarded as local minima. To determine the nature of the turning point, we need to use the second derivative. Second derivative is nothing more than differentiating the first derivative of the function. If the second derivative is greater than 0, then the turning point is a local minima, whereas a negative second derivative indicates a local maxima. Now let's move on to some special equations. There are curves that are not defined by a function but still have tangent at each point. The most common example of such would be circles. There are two major ways to define such equations. A parametric equation defines the x and y coordinates using a separate parameter. Even though the parameterization is not unique, the derivative can be obtained by using this formula. Once we have a parameterization of the curve, we find the derivatives of x and y with respect to t, then apply the formula to give the outcome. On the other hand, an implicit equation is defined in this form. It is typically difficult to make one of the variables to be the subject. So to find the derivative, we need to know about the chain rule. With the help of the sum and difference rule, we can figure out the derivative by rearranging the messy expression. One thing to note is that implicit differentiation is also a useful tool in determining standard results, especially the inverse trigonometric functions and logarithmic functions. You can practice those on your own. Differentiation is useful in real life as optimizing problems, from minimizing costs, maximizing volumes, and more. It is a fundamental concept for analysis in undergraduate. I cannot cover everything of differentiation in just under 5 minutes, but this should be enough to start you off the journey of calculus.